Okay, got a little technical difficulty there. Let's now start working on this table on page 2. So we're going to take each resistor, put it in the measuring spot. We're going to measure current and voltage for 4 different settings. So we're going to measure these, and you're going to calculate the third column later, the calculated V over I. But we're measuring current and voltage. I is current, V is voltage for the different resistors. So let's start with resistor number 1. And let's put it in the breadboard so that it's in between, so that the current flows through it. So we're going to put one end over here at the negative spot and one end over here at the positive spot. We've got our current here measuring the meter here measuring current, and this one, and it's set on the 200 milliamp range, and we've got this one set on the 20 volt range to measure the voltage. All right, power supply, we got the voltage turned, the current limiter turned all the way up, and we're going to control it with voltage. We can't go over 200 on this guy, or we're going to burn up our fuse in our meter. Okay, so let's just turn it up a little bit to about maybe 5 milliamps. That's a little hard to dial in. Okay, whatever. 5.1 milliamps, 1.32 volts, or 5.0, there it goes. So 5.0 milliamps here, voltage 1.32 volts goes there. Okay, let's get another set. Let's keep going up a little. Let's try for about somewhere in the 20s. 26.1 milliamps, 6.75 volts. Okay, that's point number 2. Let's get to point number 3. I don't know. 43.6, so point number 3 here, 43.6 milliamps, 11.24 volts. And then the highest one, can we get to 60? 60 point, let's say 60 milliamps and 16.38 volts. Everything can get in there. Okay, so that's resistor number 1, 4 sets. Resistor number 2, get it in there. In that same spot. All right, power back up. Let's say 5.3 milliamps. So now we're resistor 2, reading number 1, 5.3 milliamps, 1.69 volts. Reading number 2, 20.1 milliamps, 6.40 volts. All right. Reading number 3. Let's just go there. 43.7 milliamps, 13.92 volts. And then reading number 4, we'll say 54.6 milliamps, 17.8 volts. All right, so that was resistor number 2. Resistor number 3, again, connected in the same spot so that it's connected across the power supply through this current meter, voltage meter measuring the voltage, everything in its slots and not coming loose. Alrighty, so first reading for resistor number 3, let's say 5.6 milliamps, 0.62 volts. Let's say 23.6 milliamps, 2.65 volts. Say 50.3 milliamps. Come on, hold still. 51 milliamps, 5.72 volts. Let's say 99, come on. 98.2 milliamps, 11.86 volts. It was not holding very steady. We'll just go with it. Okay. And, woo, that one was hot. Maybe we shouldn't go up that high. I'm not sure what the current ratings on these guys are. It's probably by watts. Maybe a quarter of a watt or something. We'll not put this one up quite that high because resistor number 3 is toasty. Okay, let's start off here. 3.9 milliamps, 0.37 volts. 27.5 milliamps, 2.63 volts. 41.3 milliamps, 3.94 volts. 60.5 milliamps, 5.77 volts. Okay. All right, so that should have, you should have all the data filled in on here for the graphs. Calculate these guys, just voltage divided by current. They should match closely what the resistor values are supposed to be. Up here, now go to Excel, make a graph of V versus I for each of these resistors. Plot V as the Y, I versus the X, so that the slope, Y equals MX plus B, the slope, V equals R times I, so M is R if you plot V versus I. All right, so do that. Record those numbers here in the slope measurement for the resistance. Those will be kind of our best estimate from this method. All right, now we put the DMM numbers in here. So we have things to compare. And so we have DMM numbers. That was what we have those on here. Okay. Now we're going to do a combination. We're going to take two light-coded resistors. So these are our brown, black, browns. We're going to put in parallel. And we're going to calculate it. So you're going to do some calculations here with the slope numbers that we just got from Excel. And then we're going to measure it with a DMM. And then we're going to do a V versus I thing like we did just a minute ago with the other ones. So let's put these two in parallel. So to be in parallel, we put one end connected to one end of the other resistor and the other one to the other end. So they're both touching the same two rails. So they're in parallel with each other. Let's, for a minute, turn off the current meter. And let's change this guy to ohm, back to ohms. So it's going to be measuring R now. Let's just put it on 200 ohms because these are our 100 ohm nominal, so that we would expect two in parallel. Like resistors put in parallel, their value should just cut in half. So this should be about 50 ohms, which we are reading 52.3 ohms for these two guys in parallel. So again, the voltage meter is connected between here and here. Oops, here and here. And so it's measuring the voltage of the parallel combination. This is opened up because we turned the meter off. And so the ohm meter is measuring the parallel combination. Okay. And now let's go back to volts and do it with V versus I again like we were doing before. So we're going to turn the power, make sure the voltage is down, turn the power supply on. So this is a tiny resistance, so we don't want to put too much to it. The current will go up fast with small voltages, but we're on milliamps now, so let's turn this up and watching the current. Alrighty. Okay. Just a little paranoid, nothing's happening. There we go. Something was not registering. Okay, so we're connected. Let's just go ahead and take this somewhere, good number. All right, so use this as your V to I ratio for the last column of that table. 42.7 milliamps and 2.24 volts. Again, V over I should be about 50 ohms. Okay, so you're going to do some percent error kind of, or percent difference kind of calculations there. But we just got this V over I. Use those last two voltage and current numbers to calculate your V over I for the two in parallel. Alrighty, now we got to build this thing. Okay. Doesn't say where we have to put which resistors, but we're going to have 2 resistors going to be in parallel, and then we're going to have 2 other ones that are in series with that parallel combination. Alright, so we got these 2 in parallel already. So let's, well actually, yeah, let's just kind of back these up so we have a little more room to build. I'm going to take the 2, come on out there, put these in this row over here so we have a little more room to build, and let's take these 2 parallel ones and make some room on one side for one of the series resistors and other side for the other. So these 2 are in the same row, right? So these 2 are in parallel. Both of them are in 31 here, both of them are in 20 or in 18 here, so they're in parallel, but they're just floating in space because nothing else is connected. So that's R3 and R4. So R3 is the top one, R4 is down here, and let's take R2, our purple red one, or no, our orange brown one, put R2 here. So the way I'm doing it is R3, R4, R2, I'm going to put R1 here. But this is the plus of the source, this is the minus of the source. Okay, so I've got R2 there. Whoops. Nope, this is wrong. R2 is towards the minus of the source, so this is the minus of the source side over here. I'm putting R2 over here. Get in there. So one side of R2 is connecting to the parallel combination in row 18, and the other one is in row 10 where it goes to the negative of the source. The blue row over here is negative of the source. And then R1, which is our red-purple guy, is going to go from the parallel combination over to where the plus part of the source comes in through the meter, the current reading meter. Okay, we got that circuit built. Oh, we want to measure the resistance with the DMM, so let's turn this guy off. So it's not connected to the source, and the source is off too. And put this guy back onto ohms. Alright. Series ohms should add up. Parallel ohms should make it smaller. It looks like it might be over 200, so let's put it like this. There we go. Okay, so it's reading from here to here now. The meter is connected. The black one is over here, and the red one is over here. So it's reading the resistance of this whole combination, this chain of resistors connected through the breadboard. And it says it's 631 ohms, right? 0.631 k ohms. So 631 ohms. So put that in here. Okay. Calculated, you're going to use all the numbers we have from the slopes, right? From the previous slopes calculation, the resistance values, and calculate R1 in series with R2 and 3 and 4 in parallel in series with R2. Now we're going to do another V over I thing here for this third column. Okay, so we're going to put this guy back to measure current, 200 milliamps. This guy back to measuring volts, 20 volts. Okay. Everybody's still connected like they should be, and not like they shouldn't be. Okay. Turn the current all the way up, so it's not limiting anything. Voltage all the way down, power on. Okay, so let's turn this up till we get some sort of medium, happy medium current with the voltage. So it's a higher impedance, higher resistance, so don't get much current even though my voltage is all the way to 11 volts. So let's just stop there, I don't know. 17.5 milliamps, 11.2 volts. So we're going to use those V and I and V, to calculate R. I, 17.5 milli, 10 to the negative 3, volts, 11.21 volts. Okay, so that's that one. Does that do anything else with that? You guys are going to do some percent difference and percent error calculations. Yep, that's all we need with this circuit. Now we're on to part 3. We're going to make sure the power supply is off. We're going to take our largest resistor, an LED, and a light bulb, connect them in series. Connect jumper wires to plus and minus so that the power supply is in series with those as well. Make sure the longer lead of the LED is towards the positive because it does care. All right, and we're going to measure, we're going to just use this power supply to read the current. So we're going to get this current reading guy out, and we're just going to let the, let's get the current reading guy out. And actually all these guys go out. Let's see, this was R1, R2, I think R3, I think R4. Okay, so let's get this meter all the way out because we're gonna not measure current with the meter. I think we were successful in not blowing its fuse. I'm gonna use this guy to measure the voltage at different places. And so let's put some, on the positive probe, I'm gonna take off the banana plug and put on just a pointed probe here, like this, into the positive, so I can just kind of touch different spots and measure things. All right, so we've got our power supply here. The red is going to, the red and black are still going to the red and black rails. We've got the negative rail. Let's put the negative over here, it just feels better. The negative rail connection over here, and let's get a little jumper somewhere. Let's get a longer one. This little green jumper. So we come from positive over into here, row. Let's do row 5, I guess, if I can get it in there. Row 5. Okay, so row 5 is positive from the source. Row 33 is negative from the source. See if we can see those. Okay, so we want our biggest resistor. What was our biggest resistor? I never did. So this was like 270, and this one is 330, I think. Let's use this resistor number 2, whatever size it was. All right, and so we want it in series, this and the LED and the Christmas light bulb all in series. So put one end of the resistor here, one end in row 14. LED can come next, doesn't really matter what order. The LED has one long leg and one short leg like we saw last week. The long leg needs to go towards the plus. Let's do it like this. Long leg in 14, short leg in 18. And then the light bulb, it doesn't care which is positive and which is negative. So we'll just put one side in the same row as the LED. Come on, get in there. And 18, and then we get the other one over here in the negative to close the loop. In row 32, whatever it is there, 32 I think. You see that? It's trying to go off the screen. Stay in there. Behave yourself. Okay. All right, we want the voltage. Actually, we want to read the voltage across things, so I'm going to get the negative probe also to be a regular probe. So I can just touch here and there and measure stuff. Okay, so this is on 20 volts still, black in the common, red where it says V, and we're going to have to fill in this table. Okay, we're going to start with a real low voltage, 0.1, 1, 2.5, 3, 5, 7, 9. I'm going to try to get somewhere around there. You can just record. So the loop current, it's one loop. It's a series connection, so they all have the same current. So we're just going to read the current reading from this guy. Hopefully, it will be big enough to read. A couple sig figs, and then I'll read the source voltage from this guy. This is the source. So that's this column. And then the resistor voltage, bulb voltage, LED voltage. So I'm going to move these across each one, plus and minus, to read their voltages. And we're going to do several different points. All right, so we got plus on the left and minus on the right. So to measure the resistance voltage, I'll do this. LED voltage here, bulb voltage. I can touch the LED and this point here to get the bulb voltage. All right. Source voltage from there. All right, so turn this down, power up, and we're trying for 0.1 volts. Whoops, we went right past it. Very small voltage. Okay, let's just do whatever that is, 0.2, 0.3. Let's get it. Come on, be stable, you. Something not touching very well. Well, let's just call it 0.5 volts. Resistor voltage. Come on. All right, we're not going to be able to do the low voltage one. Let's try the 1.4 volts for the source voltage. Resistor voltage. That's small voltages. Resistor voltage 0. LED voltage. Jumping around, but it should be negative. Come on. Light bulb voltage. Okay. So bulb voltage basically is, I don't know, call it 2 millivolts. LED voltage is not working. All right, let's just check. Across here we should have source voltage 1.5. We can use this for, let's just measure the source voltage here, 1.52 volts. All right, across the resistor 0. Across the LED, here we go, negative 0.88 volts. Across the bulb 1.12 volts. Okay, let's turn it up a little. Let's try to find where some lights come on. Alrighty, we're not going to get the lights to come on. Something. It's not good. I don't think this is an LED bulb. I hope not. Let's try connecting it the other way. I wanted this to be a regular bulb. Let's try this and see if we get anything good to happen. This might be a LED Christmas bulb as well. Oh well, we'll just go with that. Okay, starting over. let's try a close, so let's ignore the readings in the paper because I was making assumptions that are not correct. So let's start with the source voltage, row 1, source voltage, 1.199 volts. The resistor voltage, 0. The red LED voltage, 0.17 volts. The Christmas bulb voltage, 0.75 volts. No lights are on. Alright, let's turn it up a little bit till some light comes on. I think they're both on just the tiniest bit. So source voltage from here to here, more than 2 volts. 4.37 for the source voltage, row 2. Resistor voltage, row 2, 0.03 volts. LED voltage, row 2, 1.78 volts. Christmas bulb reading, 2.54 volts. Okay? We don't blow out the Christmas bulb. Okay, source voltage, 7.62 volts. Resistor voltage, 2.66 volts. LED voltage, 2.08 volts. Christmas bulb voltage, 2.85 volts. Go up a little bit more. All right, source voltage, 10.07 volts. Resistor voltage, 4.85 volts. LED voltage, 2.24 volts. Christmas bulb voltage, 2.94 volts. Okay, I've kind of lost track of how many we had. So we're not reading hardly any current, actually. We have a problem. So we only have 0.1 amps in here. So I guess we better get our current meter back in here so that we can read current in the loop. All right, this guy is our current meter. He needs to be in the loop. So let's break open the plus here, take this plus out, and put this guy into the plus. Current's going to come out of the plus rail into this guy, through the meter, and then back over into the plus of this whole row here. Come on, get in there. All right, so now this meter, brown meter, current reading meter, is in series with the source. So it comes from the source, through this meter, through this resistor, through the LED, through the light bulb, Christmas light bulb, back to the negative rail, back to the source. Okay, let's try this again. Let's go 200 milliamp range. Start our table over again. I don't remember what our readings were before, so we're just going to have to go again. But we need, because we need the current. Okay, so turn this guy up. We had, what was it, somewhere around 1.1. Bad. Okay, we're reading currents, fairly high currents, with like no voltage, because the red and the black were touching each other here. Don't do this at home. Not a good idea. Okay, so we were shorting out the power supply through the alligator clips. Okay. Don't do that. Get the voltage and the current readings back over here. At least I don't think we blew a fuse. Let's turn this up. Alright, so we got small voltage readings and no current readings over here, so that is good. I have to take the current reading down a bit, I have a feeling. Anyway, this is current. Brown is current. Still not getting any current readings, but let's leave it on 20 milliamps for now. So we got 1 volt. Source voltage is 1.09 volts. Resistor voltage should be 0. LED voltage is 0.11 volts. Christmas bulb voltage is negative 0.75 volts. 7.74 volts. Was the LED negative? LED is negative 0.11. Resistor 0. Okay. Turn up some more voltage. Let's get some current going here. So let's just try to get it to where we first see the light come on. It's just barely on right there. So 4.2, well, let's go ahead and get a good reading here. 4.26 volts. Let's see if we can get some more sig figs on that current. So the current is 29 microamps. All right. What did I say? Source voltage is 4.25. Did I have these backwards? Check on the video if I had them backwards. The negative voltages probably were not negative because I probably had my red and black mixed up. All right. Source voltage 4.25 volts. Resistor voltage still basically reading 0. It's 9.5 millivolts for the resistor voltage. LED voltage 1.73 volts. Christmas bulb voltage 2.5 volts. Okay, 30 milliamp current reading. 30 microamp current reading. Let's turn the voltage up a bit. Get some good light happening. Let's try that. Current grew. Now we have 6.8 milliamps current. Source voltage 7 volts. Resistor voltage 2.12 volts. LED voltage 2.07 volts. Red Christmas light voltage 2.82 volts. Turn it up a bit more. That clicking sound always makes me nervous, but the current is still nice and low. 15.63 milliamps. Source voltage 10.10 volts. Resistor voltage 4.88 volts. LED voltage 2.24 volts. Christmas bulb voltage 2.94 volts. Let's turn it up some more. Oops. Uh-oh. What happened? Yeah, that might be all she wrote. Might have killed the Christmas bulb, I'm afraid. Or something came loose. Okay. There's something shorting out. We got no current, but we've got no source voltage. We still should have 12 volts here. There's 12 volts there. Why not 12 volts here? 12 volts here. Let's take the LED out for a minute. And let's see if we can read a voltage here. No. No voltage here. We have voltage here. No. Alright, we have voltage there. The red, nope, the red, yeah, I have the source taken out. So if we go red, if we go here to here, 12 volts, okay. We may have blown the fuse in this guy. I don't think it was that high of current though. But maybe because I was switching it over, it might have done something bad. Let's put the LED back in. Long leg towards the positive. This guy still reads nothing, still reading no current. Okay, so I think we blew the fuse in this guy because when I go across it to this side, there's no voltage there. Ah, shoot. Okay, so short this guy out. So I put both of the two leads that were connected to this one. It was going in the meter and out. Now they're just going into this red plug and then out to the black plug. So it's connected. And so turn this back on. Our light comes back on. We have a very small current reading. Actually, let's go ahead and use the 10 amp range. So putting it on 10 amps here, putting the red in this, in the 10 amp place. So that's the unfused, unprotected way to do it. But we'll get some readings. Okay, so source voltage, 12.24 volts. Resistor voltage, 6.82 volts. LED voltage, 2.39 volts. And Christmas bulb voltage 2.99 volts, and the current is somewhere around 20 milliamps or 10 milliamps, somewhere in between 10 and 20 milliamps. So this point is not a very good point. Not sure why we blew the fuse on that when we're only at 20 milliamps. I guess we can switch which meter's doing what. Do I want to do that? Blow a fuse in another one? Let's try to get a couple better readings. Let's see what happens here. So I'm going to have this meter measure current. I'm going to put it in the, it only has one, just 200 milliamp readings kind of setting. So now we're switching over. So this guy, come on. Orange guy is going to measure current. Orange guy is measuring current, and I think he can. This one can measure voltage, even though it's got a blown fuse for current. But let's see if it can read anything. Put this on 20 volts. Let's not change the settings when we're powered up. That's probably what did bad things. I don't know. Okay, so let's go with 21.5 milliamps for that 12 volt battery or current voltage source setting. Put them on the right side. Okay, 21.6. All right, let's go a little bit higher. Let's try 16.94 volts on the power supply. Resistor has 11.1 volts. LED has 2.72 volts. Christmas light has 3.09 volts. 34.9 milliamps current reading. All right, we'll stop there. Hopefully that gives you enough points here to make a plot. So we're going to do all of them. So you got current is X for all of them. Make sure you get it into amps or milliamps. Anyway, all the same, because some of them were microamps, some of them were milliamps. But that's X for all of them. And then you have, does it want you to do the power supply? All the voltages. So plot source voltage on source voltage versus this versus current, resistor voltage versus current, bulb voltage versus current, LED voltage versus current. Look at the shapes. And then ask you, do they obey Ohm's law? Things that obey Ohm's law have constant R, so they would have a constant slope. Resistor, better obey Ohm's law. It's a resistor. That's kind of the definition of a resistor. These two, probably not, because they're not resistors. All right. And they asked about the cut-in voltage. That's where they just turn on. And actually, like I said before, the Christmas bulb is, I wanted it to be just a regular incandescent kind of a bulb, but it's an LED bulb, I'm pretty sure, because of the way it acted. So it is another LED, but we'll just call it bulb for this work. But I would expect these two to have fairly similar V versus I graphs that do not look like the resistors. Okay, we'll stop there.